So I have this k-means clustering code which is written here, and we're going to understand k-means clustering using this example. Let me do a Control L to clear the console. I'm going to use a broomstick to get rid of all these. We'll do it afresh. Let me close everything here. I just want k-means clustering so that there is no disturbance. Alright. Now, there is a package called Plier. You need this, so let me load it. Now what I'm trying to do is, if we have multiple features, as in this example, say you have SAT score, top 10 acceptance, so on and so forth. If I just represent universities using SAT score and top 10, each and every university would be represented in this way. Say this is Brown University, this is Caltech, this is your CMU, this is Columbia, and this is Cornell. Just assume for now. These are the 5 data points. If I include another feature called as accept, you would have another access here. And if I include another feature, then probably you'll have a feature like that. Assume that an arrow is going into the wall there. If I give you this kind of a representation, and if I ask you, where is this? Is this data set in the space? You would say, oh yes, it is in the space. But is it towards this side? Assume that there is a mirror there. Assume that there is a mirror. Are these values on the front side of this mirror or on the back of this mirror? We need to be in a position to determine that. Can you determine? Absolutely no. Because the computer screen that you see is only two-dimensional. Maximum that we can do is we can, with great difficulty, try to plot the data in three-dimensional scale. So you'll not be able to visualize what is happening in k-means clustering if you have more than two features. You'll directly get an output and you need to interpret that. But that's fine, but I want to explain you all on what is happening behind the scenes. And that is the reason why I will be choosing only two features. Say I'm choosing SAT score and top 10 score. Say I'm choosing only those two. Yeah. From that perspective, I'm creating a new variable called X, new feature called X, and I'm trying to randomly generate 50 numbers, because I've mentioned 50 there, from uniform distribution. All right. I would have randomly generated 50 numbers from uniform distribution, right? And using this assignment operator, we are assigning it to an object called X, right? So we are randomly generating 50 numbers from a uniform distribution. And when you look at the uniform distribution, it's a probability distribution, friends. Each time I say distribution, I'm referring to probability distribution. And just to recap you all, for any probability distribution, you'll have a random variable on your x-axis, and probability on y-axis. And if you get this kind of a representation, it is called as normal distribution. Because of the shape of this curve, you're calling it as normal. What are the properties associated with this? It is symmetrical across the mean, so on and so forth. It ranges from minus infinity to plus infinity, all that. And t-distribution would probably appear somewhat like that. But as and how your sample size increases, your t-distribution would approximate your normal distribution. Yeah, and if you look at this is a uniform distribution which ranges from 0 to 1. This is a property of uniform distribution. It's a straight line. And the probability of getting any value from this uniform distribution is the same, right? Hence, when I generate random numbers, all the numbers will be in the range of 0 to 1, right? Because you're taking it from uniform distribution. We can pick it from normal distribution also. If you want to generate 50 numbers using random distribution, the function just changes to R norm. All right. So I'm randomly generating 50 numbers using uniform distribution and assigning it to an object called X. I've done so. Now let me call X. X has all these 50 values which randomly got generated now. Each time I randomly generate, I'll get a different set of numbers because it is random. And all these values will be in the range of 0 to 1. So think about this as one feature. For example, if you consider SAT score, that is one feature. So in that way, I've generated one feature called X. Why am I doing this? Just to explain you all the concept of k-means clustering, post which we will anyways do k-means clustering using this dataset. Now, I'm randomly trying to generate another 50 numbers using uniform distribution, and I'm trying to assign it to an object called Y. So let me do so. There we go. If I call Y, there we go. So your variable Y or object Y now holds 50 data points. These are also randomly generated, which range from 0 to 1 because it's a uniform distribution. Now let me combine X and Y. Using function column bind, cbind, I'm trying to combine X and Y, and I'm assigning the output of that to an object called data. Now let me call data. There we go. Here are 50 numbers which are generated. Think about these X and Y variables as SAT score and top 10 score. I'm just randomly choosing those, that's it. I could have as well chosen only 2 columns, but that's okay. I just want to explain y'all the underlying logic using very neat data set. Now, if I plot this data, pay attention, if I plot the data, you have 50 values here. And let us do this. So you have this first data point which has X 0.62. So X 0.62 will be somewhere here, maybe. And Y is 0.40, 0.4 will be somewhere here. So if I look at the corresponding value, this is the value, this one. Yeah. So this data point here is this one. So each and every data point has an X and a Y. Feature X and feature Y. Right? I've taken only 2 features. In that way, we have, since we have 50 data points here, we have 50 circles there. First step done, set it aside. Now, instead of these data points, can I know the university names? Would that be possible? Can I have the names tagged? Oh yes, but it will be very clumsy. Right? For these values, let me plot it. All you need to do is say type equal to n, and you need to provide a text. You are providing the text from this data set, which, let me click on that. This data is X and Y, and you are giving the row names of data. So if I run this, there we go. So you have all the row names there. Yeah, the University 86. There is some overlapping going on. I believe this is University 1 and 68. They are overlapping in that way, right? So you need to take a call on what makes more sense. So let me go back here and just plot data, all the values. Now, I want to run k-means clustering, and I want to run it on this data which has X and Y values here, which has X and Y values, and I want to run 4 clusters. You might ask me, hey, in K-means clustering we will upfront decide on how many clusters we want, right? So how did you determine that it has to be 4? I have randomly selected that, but the generic thumb rule is square root of n by 2, and if you have 50 data points, it is, here we have 50 data points, so 50 by 2, which is square root of 25, which is equal to 5. So we need to ideally generate 5 clusters, and this is just a crude way of generating number of clusters. We will look into something called as scree plot or elbow curve to understand how many clusters we need to generate. Okay, now, so let me run this. For now, I'm just choosing randomly 4 and I'm assigning the output to Km. Now, if I see structure of Km, I get to see all the output here. I'm going to explain each and every entry of this output in a moment, but this is not our objective. Our objective is to understand what is happening behind the scenes. Hence, I'm going to run this package called, or install and load this package called animation. Let me do that. I've already installed, so I just load that. Now, if I use kmeans.ani on the data set, and if I say I want to run 4 clusters, I'm assigning it to, this time let me assign it to km1. Yep. Now, please notice what happens in plot. There would be an animation which would go on, very interesting one. Look at that. It's taking more than what we have expected, more time than what we expected. Anyways, it depends. Each time it does different iterations. All right, here it says move centers, right? Anyways, so this is your raw data. This is your raw data. And when you run this k-means clustering, you have told that you want 4 clusters. So randomly, as part of the first step, your algorithm would assign or would select 4 data points as 4 cluster centers. Look at that. You have 4 cluster centers there. You have 1, 2, 3, and 4. Right? And this is 1 data point, second, third one, and you'll have a plus sign underneath that. So we have 4 data points which are randomly selected as cluster centers.